Welcome to a brief tutorial on how to identify calcite using the polarized light microscope. But first, a brief disclaimer, because nowadays we all need them. Under this setup, a typical calcite crystal will yield a uniform yellow color because of its uniaxial crystal structure. Basically, that just means you have an anisotropic crystal with one unique crystallographic direction and either two tetragonal or three hexagonal directions which are alike and generally perpendicular to the unique direction of the crystal face. All that sounds impressive, but it basically means you have a yellow crystal no matter how you roll it around. The next thing to be aware of is that calcite has perfect cleavage in three directions and will generally yield a rhombohedral crystal. In the right orientation, these crystals can appear cubic. Now, that doesn't necessarily mean you're going to find a bunch of perfect little rhombohedrons, especially considering calcite also contains curved crystal faces. And it's these curved crystal faces that yield conchoidal fractures and also give some of the grains the appearance of lamellar sheets. Calcite's perfect cleavage also gives rise to a different feature. On cross-section, the crystal can appear to have a step morphology. When viewed from a different orientation, this characteristic can be observed as discrete transitions in the interference colors. Now let's take a look at the refractive indices. Because the refractive index of the omega axis of calcite is between 1.64 and 1.66, you can see the dispersion staining colors of blue to magenta appear. Now here's a little trick for you in the event that you don't have a dispersion staining lens or you have a very small particle and have to go to a higher objective in order to see it. Close down your substage iris a little bit and slowly slide in your first order red accessory plate. If you're in the right refractive index oil, your dispersion staining colors will appear. Another calcium carbonate is the mineral dolomite. Both calcite and dolomite are uniaxial minerals with very similar morphology and similar refractive indices, though dolomite is a little bit higher. A third calcium carbonate that you'll tend to run into is the mineral aragonite. Now, unlike calcite and dolomite, aragonite is a biaxial mineral. The refractive indices is also quite different. The alpha runs around 1.53 and the gamma closer to 1.685. While aragonite can form a blocky structure such as calcite and dolomite, its preferred habit is more acicular. Aragonite displays a very distinct cleavage on the 010 plane. This is what lends this mineral to the elongated acicular habit. During dispersion staining analysis in 1.660, you can see that the dispersion staining colors of aragonite have shifted slightly because of the higher refractive indices compared to calcite. Now, as far as those annoying lookalikes, the good thing is calcite really only has one that you would run into in a normal situation. That's sodium bicarbonate. Sodium bicarbonate is usually observed as a uniform yellow coloration, very similar to calcite. One of the key features of this mineral is its perfect cleavage, which, unlike calcite, will tend to give you an elongated hexagonal crystal. Due to the mineral's hardness, which is down around 2.5, the surface of nacolite can appear grainy. Undamaged or newly formed crystals will have a very smooth, elongated shape. The good thing is, thanks to a very low refractive indices, down around 1.4 and 1.58, sodium bicarbonate can easily be distinguished in 1.660. Here you can see the lines extending out into the higher refractive indices, which happens to be the 1.660 refractive index liquid. Well, ladies and gentlemen, that is the end of our brief tutorial on how to identify calcite. All of this information and more can be found online or in any number of the mineralogy books that have been printed down through the ages. Have a good day.